Okay, so in class we were talking about linear regression, and I'm gonna go ahead and just summarize a little bit of what we did. So let me just go ahead and just quickly go click on a button. Let's see this. Okay, so what we said was like linear regression was just a line of best fit that minimizes the sum of squared errors, right? So we usually had two different variables, right? An x variable and a y variable. We went ahead and plotted it, right? So this is maybe some of my data. Looks something like that. And basically what we wanted to do, we wanted to make a line that best fits this data, right? We know that not every single point is going to, there's not one unique line that's going to fit through all these points. So we need to figure out one of the best lines, right? So in order for us to fit a best line through this data, right, we are trying to minimize our errors. So the only way that we can do this is if we have one quantitative data, right? So which is basically the numerical data, right? So you can just go ahead and write numerical here. That's basically what I mean. We need linearity, right? We need to make sure that everything is linear. It looks like some sort of a linear pattern. We do not want anything that looks curving or that doesn't follow anything linear at all. You cannot use linear regression. We want to avoid outliers as much as possible, right? Make sure that we don't have any outliers. And independence, we'll talk about this a little bit later, but we don't want my x and my y variable to depend on one another. So basically, the ones that you really need to watch out for is just the first three. The last one's kind of hard to prove, but the first three are going to be good enough. So then what we said was that we had a regression equation, right? It looks kind of like y equals mx plus b. And what we have, oh, there's a mistake here. This should be an a. So this is an a right here. Well, we're going to be using an in this class is y hat equals b plus ax, right? And what I said right there was the notation. B is just going to be my y-intercept. A is the slope. Y hat is the predicted y value, right? So what are the value that we're trying to predict? And E is what we call my residual. So that's just the true value. So here, this y right here is my true value. So if I actually know what the true value of y is, then that's what it will be. My y hat is my estimated value, right? Estimated. So that is the value that I use. Usually we calculate the y hat using, the equation, right? So usually this we don't have, the y we don't have, but the y hat we can calculate it using the value. So I had to give you what the y value is. The y hat value we had to calculate using the equation. Okay, so how do you find the regression equation? Here are the formulas. We're not really going to use them. So I just went ahead and put them there. Instead, what we're going to be doing is we're going to be using the StatCrunch output instead. So also some of the things that we also spoke about in class was that the slope and the y-intercept have a physical meaning, right? So the y-intercept tells us that the predicted mean y value is whatever it is when the x value is 0. So when x is 0, the y value associated with x equal to 0 is my y-intercept. My slope tells me the mean y values for the objects that are 1 unit apart on the variable. So that just kind of seems a little bit of a mouthful, but basically all it is I wrote it right here. So for every 1 unit increase in whatever x is, your predicted whatever y is increases or decreases by whatever the slope is. So if you want to go ahead and write this on your cheat sheet for your first exam, you can go ahead and write it. You just have to fill in the blank of whatever x is, whatever y is. And when I say whatever x is and whatever y is, well, what is x? Is it quantity? Is y price? What exactly are we talking about? So so these are some of the interpretations that we have. Also one thing that we also looked at linear regression output, right? So in your notes, you can go ahead and just write a couple things down, right? So the top portion right here, what we said in class was that this was my y value, right? This is my y value. I'm going to write this. So if we look at my test grade in this case, I was looking at my test grade and how many hours I studied, right? So the first line just tells me whatever my Y value is. My independent variable, my hours studied, this is what my X value is. So this is just X value. The third thing is my regression equation. So this tells me what my equation is, right? So yeah, that's what we got. So this tells me, like, if I wanted to go ahead and predict my test grade, if I studied for 5 hours, what is going to be my test grade, then all I got to do is just plug in 5 hours here, multiply it by this number, add it to this, and I'll get my test grade. Here, very self-explanatory, sample size. This next one is my correlation coefficient, right? So you can see my correlation is very, very strong, which is good. And this R squared, we will talk about it in later on video. Okay, you don't need to worry about this last one. Don't even worry about this. Not relevant right now. Okay, so we're gonna go ahead and do this problem, and I'll do it in the next video. But I did want to go ahead and recap a little bit of the things that we did in class. So remember, linear regression, to just summarize, we want to go ahead and have a line that best fits our data, right? These are the qualifications that we need our data to be, right? Quantitative, linear, and hardly any outliers. And then at the same time, the only thing that you really need to really know is how to interpret, right, the slope and the Y-intercept. And something else that you really need to know is how to go ahead and find all this information from the output. So if I give you something like this, you need to be able to know what each row represents. So in the next video, we'll do an example of questions that I might put in the exam.